Now that we've gone through greatest common factor and least common multiple in more detail, hopefully that'll make the next section, or the rest of this section, a little bit easier. So the next thing that we're going to look at is a fraction review. In order to do this, we do want to know how to add, subtract, multiply, and divide numbers. We want to be able to find the greatest common factor, or at least a common factor. Doesn't necessarily need to be the greatest. And we also want to be able to find the least common multiple, or at the very least a common multiple. Upon completing this presentation, you will be able to write fractions in lowest terms by hand, and be able to add, subtract, multiply, and divide fractions and mixed numbers by hand. One of the things that I do want to emphasize is that even though you are allowed calculators in this class, I would prefer, and I am going to require on quizzes and exams, that you be able to do this by hand, mostly because when we get to Chapter 8, we will have variables involved, and therefore you need to know your rules for adding, subtracting, multiplying, and dividing fractions, so that when we get to Chapter 8, you can do it without a calculator. The final operations that we want to look at is adding and subtracting fractions. Now, adding and subtracting can be classified into two different categories. The first one is subtracting fractions with like denominators. Like denominators mean that they are the same denominator. In terms of our operations, adding and subtracting fractions with like denominators is relatively easy. So what we're going to do in order to add and subtract fractions with like denominators, we're going to add or subtract the numerators and keep the same denominator. From there, we want to reduce the result if possible. So let's look at some examples. If we look at 3/11 plus 4/11, well, hopefully you're okay with this being 7/11. You can think of the denominator being kind of like a unit. If you had 3 feet plus 4 feet, you're going to end up with 7 feet. Same thing here. I have 3/11 and 4/11. That's going to equate to 7/11. And that's it. We cannot reduce the fraction, and so we are done. For our second example, we have 11/12 minus 5/12. So same thing, I want to subtract the tops. I want 11 minus 5 is 6. Keep the same denominator, 12ths. So we end up with 6/12. Now from here, we should simplify the fraction if possible. 6 and 12 have a greatest common factor of 6. So I can divide both the top and the bottom by 6, and I get 1/2. That takes care of adding and subtracting fractions with like denominators. Why does this work? Let's go ahead and emphasize that again. Again, think of adding and subtracting objects. For example, 3 oranges and 4 oranges is equal to 7 oranges. Similarly, 3/11 and 4/11 is equal to 7/11. Realize, though, that when adding objects, for instance, you stop at 7 oranges. You can't do anything else with it. When we talk about fractions, realize that this object analogy only applies to when we are doing our initial step, which is adding the numerators and keeping the denominator. From there, we do need to realize that we are talking about fractions, and that we do need to go ahead and simplify if possible. So far, you have seen that multiplying fractions is not that bad, dividing fractions isn't that bad, and adding and subtracting fractions with like denominators is pretty easy as well. So why is it that we hate fractions? Generally, fractions becomes an F word when we start talking about adding and subtracting fractions with unlike denominators. This is the one that's going to be different than everything else, and once we do this, we do need to keep in mind always what operation are we working with. If you notice that every single one of these has a different procedure. So, when we talk about adding and subtracting fractions with unlike denominators, the first thing that we want to do is convert mixed numbers to improper fractions and convert whole numbers to improper fractions. Now, we do have a quick note here. Unlike multiplication and division, converting to improper is not required, but it does make it easier. If you choose not to convert, you will need to remember the different cases that involve carrying or borrowing with fractions. Carrying and borrowing becomes a lot more challenging when we talk about fractions than it does when we talk about whole numbers and integers and decimals. Me personally, I prefer to convert mixed numbers to improper fractions. That way I know whenever I see mixed numbers, my first step is always convert to an improper fraction, irregardless of what the operation is. So, from there, what we want to do is we need to determine the least common denominator, or the LCD. The least common denominator is the least common multiple for the denominators. Recall that a least common multiple is divisible by a set of numbers, and so here I want a number that is divisible by each denominator. Remember that least, I want to do the opposite. I want to make these bigger if I need to change them. From there, we want to rewrite each fraction as an equivalent fraction with the LCD. We're going to need to multiply the numerator and denominator of each fraction by the same number. Note that each fraction, I may be multiplying each fraction by different numbers, but the tops and bottoms of each individual fraction needs to be multiplied by the same number. From there, we want to go ahead and add and subtract the like fractions. So we're going to add or subtract the numerators, keep the same denominator, and then reduce the result if possible. So let's look at some examples. Example A, we have 1/5 plus 3/4. So my first step is I need a least common denominator. My LCD, what is a number that is divisible by 5 and by 4? It's not going to be 1 because 1 is the greatest common factor. I want to go the other direction. What is a number that is divisible by 5 and divisible by 4? Hopefully you came up with 20. "20 is divisible by 5, and 20 is divisible by 4. From here, I want to go ahead and multiply each fraction so that I have a denominator of 20. So my first fraction, in order to get from 5 to 20, I need to multiply by 4. And just remember the basic rule, whatever you do to the bottom, you have to do to the top. Similarly, with my other fraction, how do I get from 4 to 20? We need to multiply by 5. And again, whatever I do to the bottom, I do to the top. So let's see what we get here. We get 4 times 1 is 4, over 4 times 5 is 20, plus 3 times 5 is 15, over 4 times 5 is 20. We now have like fractions, which means that I can go ahead and combine my tops, my 4 and my 15, to give me 19 over, keep the same denominator, 20. If you have 4 20ths and 15 20ths, you should end up with 19/20. The fraction does not reduce, and therefore we are done. Let's go ahead and move on to example B. Example B, we have 3/4 minus 1/6. So what is my LCD? We're going to do this problem twice. The LCD, you can go ahead and use 12. 12 would be a common denominator. It is also the least common denominator. 12 is the smallest number that is divisible by 4, goes in 3 times, and divisible by 6, it goes in twice. So let's go ahead and do this problem using an LCD of 12. In order to get from 4 to 12, we want to multiply by 3. And again, whatever I do to the bottom, I do to the top. For the second fraction, in order to get from 6 to 12, I want to multiply by 2. Again, whatever I do to the bottom, I have to do to the top. And so now if we go ahead and multiply these out, we get 9/12 minus 2/12. And now I can go ahead and subtract 9 minus 2 is 7/12. Now, if you recall, when we talked about greatest common factor and least common multiple, one of the things we said was that you don't necessarily have to find the least common denominator or the least common multiple in most problems. It just makes it easier. So this time, just to show you that this does not matter, let's just find a common denominator. Now, a common denominator for this problem could be 24. You can always go ahead and multiply the denominators together and you will have a common denominator. Let's go ahead and look at this problem again, but this time let's use the common denominator of 24. In order to get from 4 to 24, I want to multiply by 6. And in order to get from 6 to 24, I want to multiply by 4. So if we go ahead and do this, we get 6 times 3 is 18/24 minus 1 times 4 is 4 over 6 times 4 is 24. We can go ahead and subtract the numerators. 18 minus 4 is 14 over 24. Now, one of the things about common denominators versus least common denominators is this. With common denominators, if it is not the least, you are guaranteed that you will have to simplify the fraction. Least common denominator, you might have to simplify the fraction, but it's not guaranteed. So, 14 and 24, these are both divisible by 2. If we divide by 2, we get 7/12. And now notice that these two answers are the same. So, as mentioned, it does not matter whether you go common denominator or least common denominator. Of course, as your numbers get bigger, it is easier to always try to find the least common denominator, as sometimes we may not want to just multiply the denominators together. Let's look at one final example. Let's look at example C. C, we have 2 7/15 minus 1 4/5. Recall that when we talk about mixed numbers, the first thing that I want to do is convert it to improper, just because that way, whenever I see mixed numbers, I know I want to convert to improper as my first step. So if we convert to improper, we are going to get 15 times 2 is 30, plus 7 is 37 over 15. For my second one, I get 1 times 5 is 5, plus 4 is 9 over 5. So now we want a least common denominator. My least common denominator, for this one I don't want to multiply. 15 times 5 is 75. That's going to be pretty big. And we should be able to do these without calculators to assist us. If you notice here, 15 and 5, they do have a common factor of 5. So on this one, 5 is the common factor. 15 is the least common denominator. 5 does divide into 15. Alright, now that we have our fractions set up, we can go ahead and rewrite with a common denominator. My first fraction already has the common denominator of 15, so I can go ahead and leave that one alone. My second one, I need to multiply 5 by 3 in order to get to 15. And whatever I do to the bottom, I need to do to the top. So I get 9 times 3 is 27 over 5 times 3 is 15. From there, we can go ahead and subtract the tops. 37 minus 27 is 10 over 15. And now, can we reduce this? Do 10 and 15 have any common factors? Yes, they do. We can divide both of them by 5. If we do this, we get 10 divided by 5 is 2, and 15 divided by 5 is 3. So note that even when we have least common denominator, occasionally we will have to go ahead and simplify the result. So that takes care of adding and subtracting fractions with unlike denominators. So operations with fractions, when are we going to see this again? In terms of simplifying fractions, whenever we are working with fractions, unless specifically stated, answers must always be reduced. They don't necessarily need to be converted to mixed numbers, but your fraction always needs to be reported in lowest terms. In terms of operations with fractions, fractions can show up in any type of problem that we look at. Some instances that we will see this semester is solving linear equations, slope of a line, and the quadratic formula. We will also expand these concepts when we talk about rational and radical expressions and equations. Rational expressions are going to be fractions that contain variables, and radical expressions are going to be expressions that contain square roots, cube roots, etc. We will see it again with expressions and equations.